TMG, esteemed SMC members, IMD officials, guests, IMSA members, and dear colleagues. It is my proud privilege to welcome you all to this special event, which is part of the IMD's historic 150th anniversary celebration. This year marks a significant milestone in IMD's journey, which began in 1875, and we are very much proud to be a part of this momentous occasion. Today's session presents an exciting opportunity for all of us to explore the vital connection between meteorology and the space sector. And we are honored to have Shri Nilesh Desai sir, who will enlighten light on the significance of space sector in supporting IMD. As we all know that the IMD has been at the forefront of meteorological services in India, playing an instrumental role in weather forecasting, climate monitoring, and disaster management. Over the last 150 years, IMD has not only contributed to the scientific community, but has also provided invaluable support to various sectors such as agriculture, aviation, maritime, disaster response, and among many others. Here, I'm also happy to mention that IMD and SAC has long-term association for providing various meteorological applications in India. To begin today's celebration, we are honored to invite our esteemed dignitaries on the dais. Shri Nilesh Desai sir, Director Space Application Center, ISRO Ahmedabad. Dr. M. Mahapatra sir, Director General IMD. Dr. Rashmi Sharma ma'am, Deputy Director IPSA. Dr. Dear Rajak sir, Chairman IMSA. Let us extend a warm welcome to all our esteemed dignitaries with a grand round of applause. Thank you. Now, as we continue with this momentous occasion, we will begin with the presentation of bouquet to our esteemed dignitaries, a small gesture to express our gratitude and appreciation for their invaluable contribution for our national development. I request Dr. Suchandra to kindly present a bouquet to Nilesh Desai sir. I request Dr. Neeru to kindly present a bouquet to Dr. M. Mahapatra sir. I request Dr. Nirja to kindly present a bouquet to Dr. Rashmi Sharma ma'am. I request Dr. Arun to kindly present bouquet to Dr. Dear Rajak sir. Thank you. To begin, we are honored to have Dr. Ashok Kumar Das, Scientist Staff and Head, Med Center, Ahmedabad, with us today to deliver the welcome address. I invite Dr. Das on the stage. Thank you, sir.
Namaskar. Good afternoon. Respected Honorable Shri Nilesh M. Desai sir, Director Space Application Center. Honorable respected Dr. M. Mahapatra, Director General, India Meteorological Department. Respected Rashmi Sharma Madam. Respected Dr. Ram Rajak ji. Namaskar and good afternoon. India Meteorological Department is celebrating an extraordinary milestone during 24-25 in completion of 150 years of services to the nation as a national principal government agency in all matters relating to meteorology and allied subjects. In order to celebrate this momentous occasion in a befitting manner, a series of talks is planned by distinguished scientists and on various themes. I am deeply honored and privileged to extend a warm welcome to Honorable Shri Nilesh M. Desai, sir, Director, Space Application Center, Ahmedabad, for a popular talk on the topic, Role of the Space Sector in Supporting IMD. Welcome you, sir. The program is jointly organized by India Meteorological Department, the Indian Meteorological Society, Ahmedabad chapter, and the Space Application Center, Ahmedabad, here at Yaspal Auditorium. We are privileged to have distinguished audiences with us today, both physically here at SAC, Ahmedabad, and virtually across the country, mainly from India Meteorological Department, Ministry of Earth Sciences, NCMRWF, IITM, disaster management authorities, universities, various research institutes, IITs, and researchers and students. A warm welcome to all of you in this significant and insightful talk. Thank you.
Thank you, sir. Now I am pleased to invite Dr. M. Mahapatra, sir, to present the today's opening remark.
Namaskar, good afternoon to all of you. Respected Shri Nilesh Desai sir, Director, Space Application Center, Rashmi Madam, Rajak sir, distinguished participants for this special popular talk on role of space sector in supporting India Meteorological Department. Dear students, researchers, academicians, colleagues from various central and state organizations participating online and offline in this event. At the outset, I express my deep gratitude to Shri Nilesh Desai Sahab for kindly agreeing to deliver this popular talk as a part of the celebration of 150 years of India Meteorological Department. I also express my deep gratitude to Indian Met Society, Ahmedabad chapter, Space Application Center, Ahmedabad, Meteorological Center Ahmedabad, for jointly coordinating and organizing this momentous event. As all of us know, India Meteorological Department came into existence in 1875, but the story of the establishment of IMD goes back little earlier, when the science of meteorology was spreading its wings in different parts of the globe. In India, it was being taken up by the amateurs. There are many amateur scientists or people interested in science of meteorology who started taking the observations. The story goes that in 1785, the first amateur observation started from Calcutta. In India, it was after that, in 1793, the meteorological observations was established, which is popularly called as Madras Hot in Chennai. The people were dying, loss of lives were not able to be counted, loss of properties were breaking the backbone of the country in Chennai. So there was a group of people working in SID Society of Bengal who could understand this, and they lobbied for establishment of a meteorological committee at that time, able to be counted, and their lobby could not succeed for so many years. While the country was fighting for first hour of independence in 1857, they were fighting to establish this meteorological committee. So finally, some regional committee was formed, which could not serve the purpose because the data needed to be standardized, data needed to be qualified, and data needed to be accumulated in one place, data needed to be analyzed, and some inference has to be drawn. That was the objective of establishing the meteorological committee. So finally, in 1864, two massive cyclones came. Then a standardized method of measuring the informations and communicating and taking a decision on the same day was established in 1865 with the port warning. After that, in 1866, 1867, two consecutive droughts. So all these compelled the then British India to establish in 1875 the meteorological committee, and meteorological reporter was appointed. And gradually it took different names, it came under different organizations, and now it is the India Meteorological Department. It has spread its wings not only within India, but its services are provided to many countries in Southeast Asia, Middle East. But all these happened because of the specific intervention by the space sector. When we think about the service of meteorology or science of meteorology, we'll find that even though there has been some discoveries or inventions with respect to the processes, even by the end of 1800 or beginning of 1900, say for example, El Nino and La Nina, the basic breakthrough came with respect to understanding when the satellite era started in 1960s, and more so when the satellite in India was established in 1982 and 83. Of course, there has been a struggle. Desai, I think we'll talk about that. I should not speak now. But I want to mention here that satellite played a major role in basic understanding, in predicting, and in improving the societal applications of weather and climate sciences. So when we thought about organizing a lecture, we thought that Director SAC is the best one to think of in mind while you go for a popular talk on the role of space sector in supporting IMD. So on behalf of India Meteorology Department, on my personal behalf, I express my gratitude to Desai Sahab for agreeing to the proposal and appropriately agreeing to present the role of space sector in supporting IMD. The collaboration of IMD and ISRO has been exemplary in the world, and it is growing day by day. And I am sure this collaboration will enhance further, and we together can address the science gap, can avail the opportunities, and can improve our services, not only to the nation, but also to the world. I thank all of you, those who have joined today, online, offline, to make this popular lecture a success. Thank you very much.
Thank you very much, sir, for your opening remark. Next, I am pleased to invite Dr. Rashmi Sharma ma'am to provide a brief introduction of our distinguished speaker, Shri Nilesh Desai, sir.
Thank you, Indrani. Esteemed dignitaries on the dais and my colleagues from MOES and from ISRO. Greetings to all of you on the occasion of 150th year of celebration of India Meteorological Department. On this momentum occasion, it is an honor and privilege for me to introduce today's speaker, Shri Nilesh M. Desai, distinguished scientist and director of Space Application Center, Ahmedabad, is a top ranker and gold medalist of 1985-86 Bachelor of Engineering, Electronics and Communication batch of LD College of Engineering, Gujarat University. He started his professional career at SAC ISRO in the year 1986 with the Microwave Remote Sensing Program, popularly known as MRSP. In his 35 years of dedicated service to the nation in the space sector, he was involved in design and development of ISRO's microwave remote sensing payloads. He was also involved in the development of many advanced and synergistic applications involving Earth observation, navigation, and communication technologies to benefit the society, to aid in the governance, and to help in the strategic uses. An engineer par excellence, Shri Nilesh Desai ji has successfully led the design and development of ISRO's airborne and spaceborne microwave payloads like C-band synthetic aperture radar, RISAT-1, OceanSat-2, and SCATSAT-1 scatometers. Chandrayaan-2 orbiter SAR and Chandrayaan-3 lander altimeter along with hazard detection and avoidance processing system are the ones which are remarkable ones. Design and development of different types of user receivers for indigenous Navik, satellite, and SATCOM, along with high throughput communication satellites are remarkable achievement of his career. Prior to taking over as the director of the center, he served as deputy director of microwave remote sensing area and SATCOM and SATNAV advanced applications area. His motivating leadership led the center in developing and strengthening the space infrastructure and its applications. Many state-of-the-art technologies utilized in the pilot projects were used in real-time governance and strategic purposes. SAC's strong, enduring, and engaging partnership with MOES and specifically with India Meteorological Department is testimony of his continued support and encouragement. He has authored about 175 technical papers. Many of them were presented in the national and international conferences. He is the recipient of ISRO Performance Excellence Award, ISRO Individual Merit Award, and ISRO Team Award for RISAT-1 payload design, realization, and for the data products. His energetic and enthusiastic leadership enabled various professional and outreach activities like Vikram Sarabhai Space Exhibition, Smart India Hackathon, lectures in engineering and science on National Science and Technology Days, which has inspired many young generations. He is an active and contributing life member of many professional societies like Indian Society of Remote Sensing, Indian Society of Geomatics, Astronautical Society of India, and Indian Society of Systems for Science and Engineering. He served as the National President of ISRS Executive Council, and presently he is Vice President of Indian Society of Systems for Science and Engineering, Ahmedabad chapter. With this brief introduction, looking forward to your exciting talk, sir. Thank you.
Thank you, ma'am. And finally, the wait is over. We are truly privileged to invite Shri Nilesh Desai sir to take the stage. Sir, we are eagerly look forward to your address on the crucial theme, the role of the space sector in supporting IMD. We are truly fortunate to hear from you, sir, today. And please join me, everyone, in welcoming Sir Nilesh Desai sir with a grand round of applause.
Thank you, madam. Thank you, Rasmi madam, for a very long, elaborate introduction. So George Bernard Shaw used to say that his preamble used to be very big, long one, and his play used to be very short. So I will also try to follow that my presentation will be very short because I don't know the subject. That is the problem. What Rasmi madam didn't tell was that my birthday and her birthday are on the same date. Not a very worth day to remember, April Fool's Day. So at the outset, let me welcome all of you for this lecture. Although I've slightly changed the title, Space Technology for Resilient Weather and Climate. And I thank Dr. Mahapatra ji for giving me this opportunity, 150th year of IMD. It is a big achievement and they are celebrating hopefully in a big way throughout the year. Dr. Mahapatra, all of you know, is a weatherman of India, and Rasmi madam told me that he is also a cyclone man of India. So both rolled into one. So welcome, Mahapatra ji. So I'll try to cover some of the aspect. As I said, I don't know the subject, meteorology. It is a difficult subject. I know something related to space technology. So I'll try to see if I can do justice to this. And I was not very keen or to give this lecture because, as I said, I'm not an expert on this. But some of my friends told me, and by whatever I tell, it will be that disclaimer I always put that it will be in a lighter vein. So don't take it very seriously. So my friend told me that what is great in that, even otherwise weathermen, Indian weathermen, it is when they predict weather, they are always wrong. So you can also tell whatever you want. So this is not to demean their capabilities. All of you know that Indian tropical climate is very, very difficult to predict. And our people, weathermen, have done really a remarkable job predicting Indian weather in such a difficult situation. Even if American scientists predict Indian weather, they will be always wrong. So in that scenario, the infrastructure and the capabilities built by IMD over last 150 years are really very remarkable, and I salute them for all these achievements that they have gathered all throughout these years. So let me once again compliment and congratulate IMD on 150 years of their existence, and I'm sure that they'll go great way further strengthening the infrastructure as well as the capabilities. And ISRO is trying its all the capabilities to enhance the prediction accuracies of what weathermen are doing. So with these few words, let me take you to this journey of space technology, how we have tried to supplement the efforts of IMD over all these years. Next. So of course, ISRO has been working on various fronts, starting with satellite communication, navigation, remote sensing of different types, whether it is optical, electro-optical, or microwave, space science, exploration, and planetary exploration. And that has generated a lot of hype, especially after Chandrayaan-3, all of you know that. But the major activities which our application scientists do, whether it is related to ecosystem or protection of environment, climate related and atmospheric studies, oceanography related activities, water resources related actions, or various geoscience, hazards and disaster management. So we have been working in conjunction with various ministries, and IMD had been our major partner as far as weather and climate studies are concerned. So one of the major component of Earth observation, whether it is microwave, using microwave radars, radiometers, or electro-optical camera systems, whether it is imager or sounder or earlier radiometers. So they have been the major element in doing the climate and environmental study. Next. And the scenario will slightly change with the introduction of space reforms. All of you know that new space has come in place now with the earlier we used to work in silos, in isolation. So ISRO was developing sensors and then we were scouting for the actual users. Somebody should use our satellites. And of course, IMD has been a willing partner to that. So that way we had a very long association with them. But the problem was that we first used to define satellite, launch it, and then search for the actual users. And many times users felt that what they needed is not coming from the sensors. So there was always a dichotomy related to that. But now the approach is that we are going back to what we call, because when we started our space program, Sarabhai insisted that if you want to build satellites or launchers or hardware, before that you should know how to use a satellite for any applications. It started with the application or result-driven approach. It went a full circle, and today again we are back to that approach, that we should be a user-driven approach or application-driven approach. So that is how now all our future missions will be defined. At first, we should find a user who will come with his requirement, and then we propose a satellite or a sensor pertaining to the requirement of the user. And if user is satisfied, then only it gets funded, either by the user or by government, or even private users as well. So that way now we'll be working in close conjunction with academia, then private sector, which is the non-government entities, and of course industry. There are various facets of industry, and of course the government departments, who are the one of the major users of many of the remote sensing related activities which we do. And new space policy 2023 is in place now, with government already cabinet approving that, and which insists on open science. That means all the data should be freely available to every researcher, user, whosoever it may be. And only some of classes of data only are available on a commercial basis, that they will be costing. And of course, very sub-meter level data, which has some strategic implications, they will be only under some scrutiny or under sensitive observations. So that is how it has been defined under open science. So there are strategic and sensitive projects which are mostly restrictive as far as high resolution data are concerned. But most of the data up to 5 meter anyway, it is free of cost. It is available to any user, researcher, anybody, students. And it should be available easily. People used to complain that we get data from NASA, but ISRO is never willing to give us data. So that scenario will change hopefully. And if any issues are there, you can always approach us with your observations. So this space reforms, and another facet of that, as I mentioned, was the user driven or the application driven approach. So everything will be now focused as far as the development of sensors or payloads are concerned. Next. This is SAC, from where we are having this particular lecture today. So the big antenna which you are seeing and the dome-like structure, this is the first building which came up in this area from Gujarat University onwards. So it was all a forest area where this first communication earth station of India came up almost 50 years back. So we already completed 50 years in 2022, but we are yet to celebrate that 50 years. So that way IMD is ahead of us, celebrating 150 years. We are still trying to see how we can celebrate our 50 years, and already 2 years have passed by there. So there was only one building in this area 50 years back, and today we have 50 buildings at the same place today, where we are standing here, and 2 more campuses are there, where we work on various other developments. And of course, we have a very good exhibition, and now InSpace has come up, which is the regulatory authority for all the future space activities in India. So they will be both facilitator as well as regulator for under the new space reforms. So we have given some space to InSpace infrastructure. So there is a big technical complex in our Bhopal campus where anybody, any researcher, any academic partner or startups or private sector people can come and utilize the various facilities which are available in that particular complex, as well as they can also utilize the various facilities available in our setup here in SAC ISRO or any ISRO center. So that is the big change which has come in under the new space policy. Next. SAC is a unique center compared to many other ISRO centers. We are multidisciplinary. So, and we work on the heart or the brain of the satellite, which is payload or sensor, and also the end product, which is the applications, UPYOG. And it encompasses various facets, whether it is communication or satellite navigation, optical camera systems, or both passive, and now we are starting active optical remote sensing as well with the development of LIDARs. And similarly, we have microwave radiometers and radar systems, both passive and active, under the microwave remote sensing program. And of course, all the application pertaining to each category. So in that sense, we are more like if you see our composition of human resources, we are more like an academic institution rather than a government institution. And we work in close collaboration with various industries, SME, MSME, various academic institutions, working on various new R&D proposals or technology developments. And of course, many research institutes within and outside the country. And of course, the various space agencies. And along with that, various government user departments, whereby, as I said, IMD is one of the major partners for our activities. Next, under the Ministry of Earth Sciences. Next. Just to recapture briefly, this is our remote sensing program covering land or water resources, high resolution cartography, oceanographic observations, and weather or climate related studies. And we moved from resolution starting with kilometer of resolution to 1 feet. So we moved from 1 kilometer to 1 feet. That is the achievement we have got as far as our various remote sensing, electro-optical sensors as well as microwave sensors are concerned. So that is how technology has moved ahead as far as all these developments are concerned. Next. And of course, the various missions for meteorology, because IMD being our major partner. So having started with INSET 1 program, all of you may be well aware that when we started our INSET 1 program, when we defined that, of course, we didn't have any capability those days in early 80s. So we hired an American firm, Ford Aerospace, to give them a contract for development of 4 INSET satellites. And since our resources were limited, we could not spend much more money on these satellite related activities. So we have tried to combine both satellite communication and meteorology under one platform. And that was a unique experiment. Of course, we had received a lot of flack for that because it resulted into a satellite structure which was highly unbalanced. So we need to balance the center of gravity of the satellite. So for that, we have to put up a boom which will balance the CG of the satellite. And finally, eventually, as I said, we gave order for 4 satellites. Out of that, 2 worked and 2 didn't work. In one, boom didn't open. In another one, we had a failure of the satellite power bus. So that way, we ended up with only 50% of satellites being utilized under the INSET 1 program. But of course, it was, as I mentioned, it was a unique configuration where we tried to marry both these communication as well as meteorology requirements on the same platform. And subsequent to that, we tried to develop our own INSET 2 on series onwards, our own satellites. And of course, INSET 3, under that INSET 3D was specifically meant for only meteorological observation with newer sensors like imager and sounder. So I'll come to that. And in between, we had many low Earth observation satellites specifically dedicated for various meteorology and oceanographic applications. So we'll go through that one by one. So this is in summary, and now we are ready for the GI-SAT series, which will be a game changer as far as observation from geo platform is concerned, both for surveillance as well as meteorological observation. And similarly, INSET 4th generation, which we are defining in association with IMD and other partners in MOES. That again, they are going to be the latest catching up with the world, because all of you know that we are slightly behind the world scenario as far as meteorological observations are concerned. The world has already moved to 4th generation satellites, while we are still struggling with our 3rd generation satellite with INSET 3D. So these are all the new things which are coming up in next couple of years. Next. Just to briefly give you an idea that so we had our Cartosat as well as Resourcesat series of mostly predominantly land and urban mapping related satellites. And of course, oceans under the oceanographic series, we have our latest OceanSat 3 US 6, which has been operating very well last 1 year. And of course, Saral Altica, which was a mission with France, CNES, that has also lived its life, and still the data is usable, although satellite is having slight problem related to its attitude and orbit determination, but still we are able to utilize some of the parameters using the Saral Altica missions. And of course, we have now initiated what we call some technology demonstrator satellite with our microsat series, because we are still under test phase of our SSLV launch vehicle, after which it will be handed over to private sector for operationalization. So till then, we have some scope for doing various experiments with newer sensor configuration. So again, there we have tested some of the technologies. I will come to that separately. Next. So as far as MAT observation, as I mentioned already, we started with INSET 1 series, then have this VHRR payload in INSET 2 series, where in the end, INSET 2E and 3A, we had introduced the CCD payload along with the VHRR payload. And of course, Kalpana was again a brainchild of our experts, where we utilized PSLV to launch a geostationary satellite, putting it in a GTO orbit. Of course, it could not carry much weight, but that's why we limited it to only a VHRR payload with this Kalpana 1 satellite, which was named after Kalpana Chawla. And subsequently, with the INSET 3D series, we graduated to the newer series of imager and sounder. Of course, as I mentioned, they were 1 generation behind what world has nowadays, but now we are catching up with them with our next 4th generation satellite, which has been already planned, and we have also fine-tuned the requirements in discussion with MOES teams, and we are ready for the 4th generation mapping, and just we are waiting for the final approvals from MOES as well as other user departments. So, and that is for geostationary satellite series. And of course, Bhaskara 1 and 2, they were our initial foray into the low Earth orbit remote sensing satellites. And incidentally, I think 20 November, 2 days after today, we'll be celebrating Bhaskara 2 anniversary on 20 November. And of course, OceanSat 1, which contained OCM and microwave radiometer. But so that was again a very unique combination of both optical as well as microwave sensor on the same platform. And again, it served very useful purpose for the limited time during which we could operate MSMR. Because afterwards there were some power related issues, so we had to close down one of the sensors. The MSMR was not operated subsequently. Again, it was followed by OceanSat 2 series where we replaced a radiometer with the spectrometer. And again, that was a big game changer. Why I'm saying this? Because nobody in the world had this scanning type of spectrometer, which we developed for the first time. And I was personally involved in the development related to that. And we used it as a, again, an experimental platform as far as technologies are concerned, because we were under definition and development of the big ticket radar imaging satellite sensor, where synthetic aperture radar was the main sensor. So many of the technologies, we tested it on this OceanSat 2 spectrometer. So that worked as a test bed for us. But of course, it gave very good result because as I mentioned, scanning spectrometer was the first time somebody has built here in this region, and it has been widely utilized. We had a very good collaboration with JPL for the usage of this particular data, and the basic usage was for cyclogenesis. So when the cyclone originates from ocean, from that point onwards, we can track that. Such of course, tracking was being done by the other PHRR or the INSET 3D series, but the cyclogenesis was studied using this spectrometer. And being the only scanning spectrometer in this region, it has also served very useful applications, and the whole world was using this particular sensor. Of course, there were initial troubles in qualifying the products because finally for all this MET data, oceanography data, we insist on what we call climate quality data, where there has to be the accuracy may be poor, but there has to be consistency of your product. So which was initially lacking, and we took help from our JPL friends as well. Our scientists went to JPL and we fine-tuned various algorithms. And I'm happy to say that afterwards, all our OceanSat series spectrometers, which we built as subsequent to that, they were really a world-class providing climate quality data. So that was the big learning experience for us. Of course, with the technology development of spectrometer, which again fed into as a precursor to the RISAT synthetic aperture radar development, followed by the algorithmic and other application related products using spectrometer. Of course, Megatropics again was a very big collaborative project between us and CNES France. Madras payload was a flagship payload. Of course, it worked only for 3 months. After that, it developed some issues. But we were able to utilize Saphir, which was the humidity sounder, for various MET observations. So again, that was very useful for various product generation as far as meteorology and oceanography applications are concerned. And ROSA for the first time, of course, there was a ROSA on OceanSat 2 also, where radio occultation experiment we carried out for the first time. And on operational basis, the ROSA on Megatropics provided us a lot of new information using this radio occultation and GNSS remote sensing. So that was another foray into a newer activities. And of course, as I mentioned, Saral Altica again was a collaborative project which has served its utility and life over next 10 years. So from 2013 to 2023, it gave really useful products. Of course, now, as I mentioned, we are facing some issues. In between, we developed this CatSat 1, again, as a dedicated platform on a small satellite, which again provided continuity of the OceanSat 2 spectrometer observation. followed by OceanSat-3, which we launched in 2022 November, which is now regularly providing data spectrometer observations along with OCM-3. So in summary, we had a good basket of various oceanography and meteorological sensors, which have been serving the purpose for various oceanographic as well as the MET observations, which are useful for various activities which IMD and other Ministry of Earth Science related departments carry out. Next. These are some just payload pictures of what we developed in recent years, OCM-3, and of course GISAT-1 and GISAT-1 repeat or GISAT-2. These had been, as I was mentioning, they were again a very different payloads about which we will be talking in due course. Next. These are some of the tsunami related, when the tsunami came, how oceanographic application we utilize the images to do the damage assessment after tsunami. Next. And of course, our radar program, which started with the development, of course, although it started with Samir on Bhaskara, and subsequently MSMR was the major payload development, followed by the synthetic aperture radar series, both on airborne as well as spaceborne platform, culminating in RISAT-2B series of mostly land imaging sensors, which were mostly used for more for high resolution mapping and surveillance. So they didn't have much utility for oceanographic or MET observation. But now we are going to define a big series of MDA satellites. I will come to that. So in summary, we have large plethora or basket of various radar imaging satellites, which in some way C-band being a compromise choice, they were useful for many applications related to ocean and coastal observation as well. So that way, again, it had a lot of utilities. Again, here we started with few hundreds of meters of resolution and graduated to almost 1 feet resolution with our RISAT-2B series of satellites. So again, lot of improvements in technology. And now we are eagerly looking forward to NISAR, which is a NASA-ISRO joint mission, which again has many cryosphere as well as ocean and coastal related applications. Of course, not directly related to MET observation, but they have some of the application which will indirectly feed into the various activities which MOEs carry out. Next. So these are some of the photographs of the developments which happened in last 30 years related to radar developments. And I'm happy to say that as far as this technology is concerned, we are second to none in the world. So we are at par with whether USA, China, and Russia and European Space Agency in development of scatterometers or synthetic aperture radars, and of course with high resolution agile satellites, and also with millimeter wave or sub-millimeter wave sounding experiments, which we are now going to carry out in regular manner in all our future missions related to MET and ocean observations. Next. And this is what I was referring to. So after the success of RISAT-2B series of satellite, which was more, as I mentioned, meant for high resolution mapping and surveillance applications, recently you might have heard about the sanction of the space-based surveillance related 52 satellites. Out of that, most of the satellites will be built in by private sector, and around 20 satellites are going to be built by ISRO, where SAC is going to build most of the payloads. And under that, we are defining around 4 to 5 maritime satellites. So this is for maritime domain MDA activities. So maritime surveillance along with wide area coverage. So this will have again lot of observation over oceans, and that will be meant, of course, for strategic application as well as many of the oceanographic and other observations. So these are going to be agile satellite in X band, which will provide lot of information in the maritime domain, which will directly feed into many of the activities which MOEs carry out. So these are the satellites I will suggest to IMD friends and MOEs, other agencies, to work on this and see the utility of these particular observations for their various activities as a byproduct. Because the main activity will be, of course, for strategic surveillance and other applications. Along with that, there will be AIS as well as other payloads, which will aid Airport Authority of India also. So this will be a combination of a very interesting mix of payloads on these particular satellites, 4 or 5 satellites, which we are going to build in next 3 years. Next. And of course, I mentioned about spectrometer, so we will not repeat that. So wind vector, which is one of the major product of that, and cyclogenesis. So these are the major applications of this spectrometer, which is a dedicated payload for wind observations over ocean. And of course, it has some of the land products as well, which can be utilized for different applications. But, interestingly, initially we started with a normal resolution mode, but we also have introduced what we call a high resolution mode, which can give product up to 5 by 5 kilometer or 2.5 by 2.5 kilometer grid cells. So these products are going to be, we are right now generating it on an experimental basis, but in future missions, so if IMD comes out with the utility of this particular sensor in high resolution mode, then we can think of making high resolution mode as a regular operating mode as well. So this is going to be some interesting study. And again, I will urge our weather scientists to work on this particular product, whether what way it could be useful for their various activities. Next. And it has predicted all the cyclones in a very effective way. And as I mentioned, it is the only sensor in the world which gives you this type of accuracies and determination of wind vector. So these are some of the SAR imaging products, which is a C-band applications. So again, it is a compromise choice for various activities related to whether it is Antarctica related or oil spills measurement and other things, which sea ice measurement, which many of these may feed into the activities done by IMD. Next. Of course, as I was mentioning, everybody is eagerly looking forward to the NASA ISRO synthetic aperture sweep SAR radar, which is slightly different concept from a synthetic aperture radar, where without compromising accuracies or resolution, you are having a wider swath coverage. So based on a sweep SAR concept. So again, it has many applications, and some of the major ones related to coastal and ocean application and cryosphere studies. So coastal studies, oceanography, and cryosphere observations. These are an ecosystem studies, again, are going to be the major application. And unique feature of this is simultaneous measurement of L and S band observation in both differential as well as interferometric modes. So these are going to provide very unique products, and especially for land deformation studies, which in someday in future may feed into the earthquake prediction as well. That is what people are looking forward to, whether we can have prediction of earthquake like cyclone or tsunami. Still, all of you know that we cannot predict earthquake. So this could be a precursor to some of the indicators related to earthquake prediction in future. So in summary, everybody is looking forward to these particular radar observations from the same platform. We will have L and S band observations. And I'm proud to say that this S band radar was fully developed here at Space Application Center, Ahmedabad. And the L band SAR was built by JPL, NASA, and both were integrated and brought to our Bangalore center, where it is now getting integrated with the satellite, and it is going to be launched by February 2025. Next. So these are some of the applications which I mentioned. So coastal and ocean shoreline changes or subsidence studies or bathymetry. So this will feed into some of the activities which IMD and other MOS department carry out. And of course, land deformation study are going to be a major possibility for future earthquake related studies. Which is then, of course, disaster response, it will have a lot of utility with the L and S band simultaneous observation. So all in all, it is going to be an exciting proposition for various applications in all the domains of activities which we can think of. Next. And of course, as I mentioned, we had a long-standing relationship with MOES, whether it is IMD or NCM RWF, where we have been working together for various CalWell activities, utilization projects, joint activities, radiance data assimilation techniques, which we develop and pass it on to them for usage in their meteorological models and various simulation experiments. And INQUIS again had been a big partner as far as oceanographic applications are concerned. And of course, we utilize the services for buoy measurements and for our Calwell activities, ship cruises, and many other things. And of course, satellite-based potential fishing zone related applications. That has been the high point of our initial activities when we started our OceanSat series of satellites. So all in all, we have really a very good working relationship with IMD and other departments of MOES. And we would like to further continue that and strengthen it with the possibility of including seeing through your requirements and trying to improve upon various sensors or building newer sensors into that. Next. Of course, as far as other activities are concerned, so we started with IMDPS for our INSET or VHRR series starting from 1982, as I gave you all the history about that. And so the ground segment was also built for IMD by us in collaboration with various private or foreign agencies. And with recent MMDRPS setup, and of course, recently we have now ready with the INSET 3DS product as well, so which can be easily utilized by data reception center, which is a multi-mission meteorological data reception and processing system, which has been set up at IMD. And we are also gearing up for the requirement for the fourth generation. Once we agree on the final composition of the sensors, then we can straightway embark on the other augmentation required for the ground segment related activities as well. So all in all, we have really very good collaboration in all domains, whether it is space domain or on ground segment domain with IMD. Next. Of course, this all of you know that, so I don't have to repeat that. We started with PHRR and then followed it up with INSET 3D and 3DR series, which has been now augmented with INSET 3DS. Of course, we faced some Calwell related issue. The products were not up to that mark. And of course, by international standard, they were lagging behind in some categories. So we have tried to improve upon the onboard calibration as well as the ground calibration activities. And I'm happy to say that we are now ready with the INSET 3DS products, and IMD or other users can straightaway now start utilizing that and using various products, whether it is for assimilation or various operational geophysical products derived from MMDRPS. So all in all, the products are now hopefully of climate quality or the quality which of international standards. And earlier, whenever we used to attend the CGMS, the Coordination Group of Meteorological Satellite related meetings annually, we always had that to listen about the quality aspect of our products and calibration aspect. So we were trying to do the cross calibration with C6 and many other approaches. But now we are sure that our products will be of international quality, and whatever gap areas were seen earlier in this region, we now get filled up with the observation from INSET 3D series of satellite as well as cross calibration of the earlier 3DR products as well. So we are working on the regeneration of the products of the earlier satellite as well. So in summary, we will be ready with the very good quality products for this, and I'm very hopeful that my IMD friends will agree with that and start utilizing this product. And internationally also, it will improve our standing as far as the meteorological observations are concerned. And of course, with fourth generation, we are going to catch up with the world as far as other observations are concerned. Next. These are some of the products with 6-channel imager in various whether it is visible sphere, mirror, or TIR regions. Next. Cloud mass, AOD, fog related observation. So a lot of products have been generated, they are being generated, but now with the better calibration, we are sure that we have a lot of utility for various applications, whether it is by MD or other users as well. Next. So these are the list of the products which are going to be available or are already available from imager and sounder using the MMDRPS as well as the experimental product which our team here in IPSA, they are generating on a routine basis, which are available on MOSDEC as various products, both operational as well as experimental products. Next. And as far as OceanSat series, I already told so at the cost of repeating that, OceanSat 1 series followed by OceanSat 2. So almost every decade we have the continuity of this OceanSat series of satellites. So OceanSat 3 is already now operational, and we are going to define many more generations of oceanographic applications as well as the sensors for that, where, as I mentioned, we will be moving on to, of course, we could not operate SSTM in OceanSat 3, but now OceanSat 3A is getting ready, and next year it is going to be launched from the PSLV platform, and that will fill in the gap related to the non-availability of SSTM data. So again, that will be another feather in our cap as far as the sensor is concerned, and of course for users it will be a big boon with the simultaneous availability of SSTM data as well along with other data. Next. And as I mentioned, we are on experimental precursor missions with our microsat series of satellite which we are launching. So 2A was, of course, it didn't go to get launched due to the malfunctioning of the launch vehicle. But from 2B onwards, so we had a very good observation with the millimeter wave humidity sounder, and NCM and RWF were very happy with the product which we generated on experimental basis, and they tried to assimilate it in their models. So that gave us very useful data, and it was a big learning experiment for us. It was almost, as far as specifications are concerned, it was a repeat of what we have on the humidity sounder on megatropics. So now we are sure with this technology of millimeter wave at 183 gigahertz. So we have mastered the technology, and we are going to, in INSET 3A, we are going to have a dedicated humidity and temperature sounder payload, so which will directly feed into the various requirements which IMD is looking forward to. Similarly, GNSS reflectometry for the first time we tested in microsat 2C. So again, it was a unique observation, and for us also it was a big learning with various products related to soil moisture, land inundation, as well as ocean wind speed, which we generally get from radiometer observation. So this is another way. These are the opportunity signals which are anyway available from all the navigation satellites. So there are hundreds of navigation satellites all across the various countries. So you can pick up any of the signal and do this analysis. So we tested it with both our NAVIC as well as GPS signals. So again, these are going to be, of course, right now it was tested with one satellite only, but for such observation, you need a formation of satellites like Cygnus and all. So we are now thinking of putting these receivers, GNSS or reflectometry receivers, on all our LEO observation missions. So you have to put a small receiver only, and it will give us a lot of products as far as soil moisture, inundation, ocean wind speed, as well as SWH, significant wave height. So it has large amount of application. And once we have large number of observation from multiple satellite, low Earth orbit satellite platform, it will really feed into, in an operational way, into various product generation for all these parameters. Next. Of course, all this has helped us, and we were just providing data, but this has resulted into IMD helping in saving various human lives through the space observation. So right from the beginning with cyclogenesis, where we know the generation of cyclone at a particular place in ocean, and from that point onwards with the tracking of the oceans all throughout its journey before the landfall. So that has resulted into now minimal amount of casualties. Even this few number of people also should not die. That is the attempt which all of us are geared towards. But it has been a big achievement as far as country is concerned, where we could utilize our satellite observations, and with the support of IMD algorithms, we were able to predict cyclone as well as trace its track, and save lives of so many people. Next. And of course, various science and applications, whether it is related to forecasting onto real-time observation and nowcasting. So these are going to be the major areas in which we had been working with the usage of meteorological and ocean observations. Of course, with the extreme weather events also now increasing all across the world. So satellite will have its predominance or the importance as far as the studies are concerned, especially for nowcasting of extreme precipitation events. So near real-time cyclone monitoring and various tools which we are developing, whether it is on the Scorpio with the rapid system which has been developed by our team. So all in all, we have large number of activities going on, which will help in working out the demonstrative applications using the science or the algorithms behind that. Next. Of course, storm surge and PFZ has been major activities using the multiple modeling as well as algorithm development as well as the observation from satellite. So they have been the regular product which have been used in an operational way. And we had been advising fishermen going out into deep sea with where they can have a better catch of the fishes and using a very unique combination of NAVCOM, which is a combination of satellite navigation, communication, and remote sensing. We are able to feed into this information to the fishermen at a particular time of day through the help of inquires. And that also helps into a better yield for fishermen and overall improving the overall life of all these people, apart from alerting them during the cyclone time so that they can return back in time from the deep sea. So all in all these space technologies are able to help fishermen in a big way. Of course, apart from helping our coastal as well as other applications. Next. And using Inset 3D, 3DR and 3DS products, so agromet advisories for our farmers. Again, that is another application area. And now with Agri DSS system, all of you know that Krishi DSS, Ministry of Agriculture is assigned to us in a big way, generating various drought manual implementation as well as generating the Agri DSS platform where all the information related to agriculture will be available under one umbrella so that people can, the planners and the other officers can take informed decisions as well as they can take decisions as far as the insurance claims of various farmers are concerned. So this go in a big way in improving the overall yield and acreage for our farmers as well as helping them during their tough times through the insurance claim settlement using the satellite data so that it is done in a faster way and in a more precise way. So this is going to be another area where ISAC has been working in conjunction with MOES as well as Ministry of Agriculture. Next. And of course, air quality studies, they came into prominence during COVID time. All of you know that. So when some of my application friends used to come and say okay, they have done analysis, Mehul Pandya used to discuss with me that we have done the analysis and it was, the environment was very clean. That I said that why you need all the satellite data for that? And from my naked eye, I was able to see that environment has improved like anything during COVID time because there was no movements or no factories were running, no vehicles were running. So automatically it will improve. But of course, it was during the COVID times, but even otherwise, what problems we are seeing nowadays in northern part of our country, especially in Delhi and other urban areas. So these studies are going to be very important for various observation, and ISRO is going to launch various environment series of satellites starting with G20. I'll come to that next. So whether it is AOD or trace gases observations, NO2, SO2, all these observations. And of course, other applications related to numerical weather predictions. So our team has been working all these years in improving the weather prediction methodologies in conjunction with the various NWP algorithms. And of course, now with the introduction of AI, ML and various new techniques, so further it is going to improve the prediction and monitoring of weather as in climate system. So in summary, it is going to improve our prediction methodologies in a big way. Next. We had been working with USA Australia, Japan and India, they have been working together as a Quad Space Working Group, which will now again get impetus. I think Prime Minister is there nowadays to attend the Quad Summit in Brazil. So there they have decided to adopt one of the islands, small island state, and work on various applications because all data is available. So we have to just work on cyclone related storms as well, PFZ, flooding and various energy sources related development. So initially we selected Maldives as a test case for helping them to carry out all these activities. But we developed some diplomatic issues with Maldives recently, sometimes back. Again, Maldives has come back to our fold, but anyway, we have moved to Mauritius now. So we are trying to adopt Mauritius and work on various applications of using our data from various MET satellites to fulfill these applications. Next. So we are working with Mauritius. Of course, we are going to develop one satellite for Mauritius as well for various observations. But apart from that, we'll be helping with the data already available with us and which we are going to collect through our various other remote sensing missions to help them to overcome all these problems which they face. And of course, as I mentioned, we will have a dedicated satellite for Mauritius as well. Next, like we had for Bhutan. So, and as far as future is concerned, you already mentioned about INSET 4th generation satellites, where we have defined a corpus of instruments, which I'll just come to that. And apart from that, working in collaboration for the Deep Ocean mission, which is one of the, again, a flagship program of MOES. So again, how we can help in the contribution in the Deep Ocean mission. So how space and ocean can come work together for the benefit of the country, whether it is generation of coastal products or impact of climate change on various coastal activities. So these are going to be another interesting areas of working together on different activities. Next. And of course, again, as I mentioned, this is going to be a game changer. We are ready with the satellite and it is getting shipped to Bangalore for integration with the satellite. And apart from a standard surveillance observations, where it will provide 45 to 50 meter images of the land area, it will also give a lot of meteorological observations. And this is again going to be a very important element in our remote sensing arsenal. And again, all of us are now with the approval of the SBS3 program. We are going to shortly launch this particular GISAT-1 repeat program, which will help in a big way for the various activities for meteorological observation. Next. And of course, GNSS meteorology, I already mentioned about that how we are doing GNSS remote sensing, same way how we can do meteorology using ground-based as well as space-based GNSS meteorology, using the signal of opportunities which are available both in L and S band from various navigation satellites. So again, this will open up a lot of research areas also for application scientists in both the departments. Next. And this is the G20 satellite which Prime Minister has announced during the presidency of India last year. So we have already defined these environment monitoring sensors for polarization sensor, then environment sensor for atmospheric composition and advanced climate study, and especially forest fire detection. Next. And then we have a hyperspectral millimeter wave. Again, it is being developed for the first time. Such a large number of channels, 100 channels in millimeter wave domain will be there. And so these 4 sensors are going to be there from Indian side. And then we are waiting for the other partners, other 20 countries to provide us the sensors, which will go into the satellite, which is going to be provided by India. So already government has sanctioned budget for that. And we will be doing a lot of studies, whether it is related to particulate matter or greenhouse gases, or as I mentioned, forest fires, as well as temperature and humidity profiles using the millimeter wave hyperspectral. This is again for the first time it is getting developed. Next. And this is that 100 channel sounder, which we have already demonstrated a 6 channel at 183 gigahertz. So this will be both at 50, 60 and 183. So we'll be developing this 100 channel hyperspectral sounder. Already work has started related to the hardware development. Next. Of course, insert fourth generation, as I mentioned, it will be similar to Himawari or the Met set from other countries, European geos. So it will have a large number of channels, 18 channel, and we will also include a lightning mapper as well as hyperspectral infrared sounder. So these are going to be something similar to what the world already has. It's in Europe as well as USA and Japan. So we'll be catching up with them as far as the net observations are concerned. Next. And of course, newer sensor, which we have worked together with IMD and MOES friends. So precipitation radar, then aerosol, as I mentioned, the active remote sensing using electro-optical sensor, that is LIDARs and wind profilers. Recently, we had discussion related to a differential LIDAR as well. So all in all, very exciting time as far as sensor development is concerned with the active optical remote sensing, and of course microwave we have been already doing the active part, and with the introduction of lightning mapper and various neuromorphic observations on board by doing the neuromorphic processing, so that will also add into the technology enhancement as far as ISRO is concerned. And as far as the applications are concerned, it will directly help IMD for various activities which they have already defined related to their observations, whether it is atmospheric train or convective regions, or assessing the impact of climate change on thunderstorm activity, all these aspects. Next. And apart from that, lastly, the space weather observation also we have been carrying out using geostationary, and of course with the Aditya L1 mission, where we have 7 sensors payloads, 3 in situ and 4 observing the sun from L1 Lagrange point. So again, it will feed into our understanding of space weather, followed by newer sensors, which we can define in subsequently in our future missions for various observations. Next. So we already set up a separate group to study all these activities related to space weather, and of course also related to planetary atmosphere. Of course, we are studying Earth atmosphere, but at the same time, we want to study other planets as well, especially the atmosphere on other planets, which whatever thin atmosphere is there on Mars and Venus, why it's so gaseous atmosphere, what has resulted into the nature of Venus, whether Earth will also end up being like a Venus in future, what we should do to prevent it from becoming a Venus type of planet. So all these observation of Venus will help us to overcome the various problems which Earth is facing, and the space weather studies, its impact on various satellites. That is another area of research. So a lot of our communication and navigation satellite get affected by the solar storm or weather other effects which we are seeing periodically. So these studies and observation will help us in a big way in understanding this phenomena and taking precautionary measures on our satellites. Next. So these are our Mosdek and Vedas, all of you know, they are our flagship websites. So a lot of other activities which we do are available on this particular website. So we provide the web services as well. And both the sites are very popular. And as far as meteorological and oceanographic applications are concerned, Mosdek is again very useful to people. Of course, we are also partner in international disaster charter related activities. So that also is happening parallelly, where we have set up a workstation for that. Next. So in summary, we have a very thriving metro observation oceanographic applications programs, and we have been working closely with IMD and other departments in MOEs as well as other user departments. And of course, with the new INSET 4th generation GI set and various active and passive microwave sensors, which we have planned out, including LIDAR and differential LIDAR. And of course, with the advent of new space policy, we see exciting times ahead as far as collaborative activities related to MET observations are concerned. And of course, as I mentioned, it will help IMD to make their predictions, nowcasting, forecasting, all the activities in a much, much better and accurate form as well. And of course, what I said initially was just in a lighter vein, but I'm sure with the expertise available at IMD and with the support provided by ISRO, with various space observation, will be able to overcome and solve the multidimensionality problem for weather forecasting in due course. So I wish all the best to IMD in their 150th year, and I'm sure that our collaborative actions will continue in future, and we will work together, and we look forward to now bigger funding from MOES so that our activity can continue. So thank you all for being very patient.
Thank you, Nilesh sir, for your knowledgeable and informative speech. Your insight into the vital role of space sector in meteorology for supporting IMD have been truly enlightening. And we are grateful for the depth of expertise you have shared with us today. Now, we are moving to our next segment of our program, the question and answer session. I would like to invite Dr. Suchandra and Dr. Arun to facilitate the interactive session. I request the audience, you may ask your queries to Director sir.
Thank you, sir, for your nice talk. As you were mentioning that the proposed plan for that in that 4D series, as you also said, we are looking for the Himawari satellites type. So that means whether it is with respect to the temporal resolution, increasing temporal resolution, or something else with respect to sensor and any other thing.
So I meant both ways, but predominantly what we are looking forward to is the number of channels, where right now we have only 6 channels, now we'll have 18 channel major, and followed by, as far as observations are concerned, right now we'll go with, I don't know whether how many number of satellites have been planned. We'll start with one, followed by, in same way, every 10 years generally we launch one of these satellites. Like in INSET 3D, we have 3D, 3DR, 2 satellites. So at a time, 2 satellites will be there, so that we have 15-minute temporal observation. So same will continue. So I don't know whether IMD needs better than 15 minutes as well, or so 15 minutes should be good enough.
I also request our online participants, they can also ask question to Director sir for putting in chat.
There is a question in chat box by A. Prasad. If you allow it.
Yes.
He's asking, is it possible to achieve
Please
the resolution? Yes, ma'am. Is it possible to achieve the resolution of sound on par with that of an imager? If so, how? If not, why?
Possible to achieve what?
Is it
Can
possible
you please
to
repeat
achieve?
the question?
I'm repeating. Is it possible to achieve the resolution of a sounder on par with that of an imager? If so, how? If not, why? This is a question by A. Prasad.
Okay. Is how much? 1 kilometer?
Yeah, actually, this next generation, when we are talking about advanced imager, in advanced imager, we will be talking about pseudo sounder, where we will have 1 kilometer this spatial resolution, and we will have 3 sounder channel of water vapor, which currently we have in insert 3D sounder, as well as 3 of the temperature channel. So, in fact, we are going from 10 kilometer insert 3D sounder. We are going to 1 kilometer or 2 kilometer sounding in advanced imager insert 4th generation. And 10 kilometer, we will be having hyperspectral sounder on the 4th generation.
Thank you, sir. Other participants are requested to put their queries if they have.
Online participants, you can also ask questions also directly, rather than putting in chat. Any other questions? Audience? Thank you. Now, as a token of our gratitude and appreciation for the valuable insight shared by Nilesh Desai sir, we would like to proceed with the felicitation of our distinguished speakers. I request Dr. M. Mahapatra sir to kindly present a token of appreciation to Shri Nilesh Desai sir. Dr. Suchandra, you may please kindly accompany Mahapatra sir. This gesture reflects our deep respect and acknowledgement for sir's significant contribution to the field of science and his vital role in supporting meteorological advancement. And I request audience for a very big round of applause for that. Now, to conclude today's program, it is my honor to invite Dr. D.A. Rajak sir, Chairman IMSA, to deliver the vote of thanks. Rajak sir, please.
Thank you, Dr. Indrani. Good afternoon to one and all. It is my honor to put on record this vote of thanks to each and everyone involved in organizing this very important lecture related to celebration of 150th year of IMD. First of all, on behalf of IMD and IMSA, I express our heartiest gratitude to Director SEC, Shri Nilesh Desai, for accepting our invitation and delivering this lecture. A big thank you, Nilesh sir. Now, on behalf of IMSA, I express my sincerest appreciation to Director General IMD, Dr. Mahapatra, for involving IMSA and giving this opportunity to be part of this celebration. Thank you so much, Dr. Mahapatra. On behalf of organizers, I take this opportunity to thank IMD officials, SEC SMC members, including Dr. Rashmi Sharma, IMSA Executive Committee members, all other IMSA members, SEC scientists, engineers who are sitting here and who have joined online, SEC management, SEC administration, canteen support, PRO, IT&D support, CISF, and everyone who supported and helped us in organizing this program here at Yaspal Auditorium today on November 18, 2024. Also, on behalf of IMSA and IMD, I thank Director SEC for allowing us to organizing this event in SEC campus. We thank each and every offline and online audience who joined and made our activity so successful. Thank you, Dr. Suchandra. Thank you, Dr. Arun. Thank you, Dr. Pradeep Thaplial. Thank you, all the IMD officials. Thank you, Dr. Indrani. Thank you, one and all. Jai Hind.
Thank you, Rajak sir. Now I invite IMSA members and IMD officials for a group photo with the dignitaries on the stage. And I also invite all our participants to join us for a high tea at the ground floor of Yashpal Auditorium. Thank you.
Online participants are requested to switch on. We can have a online group picture. Thank you. Thank you, sir. I think we are done for today. Hello.